Hello dear students, I am Sadishan Nair. Today, let us learn differentiation. Before I begin the topic differentiation, we should just recall the word limit, the meaning of continuity, and hence we will go for differentiation. So let's know what's about limit. The limit of a function is nothing but the value of function as and when x close to a particular value. So I will explain this with an example. So let us consider an example for the introduction of limit. Look at this simple sum, let f of x is equal to, look at here, let f of x equal to mod x at x equal to 0. So as I told you, we should verify what is the value of this function when x is equal to 0. It's quite clear. When x equal to 0, the value of f of x is mod 0 and that is 0. There is no doubt about it. But then if I wanted to know what is the value of f of x when x is so close to 0, yani in the neighborhood of 0. So let us consider one example. F of x is equal to mod x. You know the definition of mod x. Mod x equal to x when x is greater than or equal to 0 and mod x equal to minus x when x is less than 0. So we have to find the value of limit x tends to 0 f of x. Limit x tends to 0 f of x equal to mod x here, and then we have to find the value of this function when x is tending to 0. So limit x tends to 0 mod x. Now how to find it out? So let us just replace the value of 0 over here. So we will be getting mod 0 and that is equal to 0. So this is nothing but the value of function at that point. F of 0 is also equal to 0. But now my question is, if I am not interested to know what is the value of mod x when x equal to 0, we are more interested to know what will happen to the function when x is so close to 0. When x is tending to 0, what will happen to f of x? So this is what we are going to find, and this is what exactly the idea of limit. Look at the graph of f of x equal to mod x. So look here, you can easily understand that this is the graph of y equal to mod x and this is the point 0. Now when x is tending to 0, we could see that we are looking for the value of function at the neighborhood of the point 0. When I say the neighborhood, I mean the points which are so close to 0. Okay. So when I talk about the point so close to 0, it can be minus 0.9999 or it can be 0.0001. For example, I am saying. So what will happen now? You can easily understand that the value of function become, let us see, value of function. The value of function means f of x, that is mod x. The value of mod x would be so close to tending to 0, I can say, because it is equal to 0. So we have identified that the limit of the function is nothing but is the value of function in this example. Shall I go to another example to make it more clear? Look at the function f of x equal to x square minus 4 upon x minus 2. If I am interested to know what is the value of function when x equal to 2, look here, you can easily understand that this particular value of x, can we get the value of f of x? Let us see, let us substitute the value. When you put x equal to 2, what will happen? 2 square minus 4 upon 2 minus 2, that is 0 by 0. Now 0 by 0 is indeterminate form, which means we are not able to get the value of the function at the point x equal to 2. So what to do? So what is the way out? We need to understand what is the value of f of x. So what we can do now? Of course, we are not able to find the value of function at x equal to 2. So let us find the value of function close to 2. So whenever we need to know the behavior of a function at a point So what we can do? We can take a point which is close to that point. So that comes to the idea of limit again here. So I am looking for the value of f of x when x is so close to 2, the neighborhood of 2. For example, you can say 2 minus h and 2 plus h, where h stands for a small quantity, a small positive quantity. H is greater than 0, but it is negligibly small. So look at the situation now. F of x, we are finding the value of function at x equal to 2 minus h. So what will be that? F of 2 minus h. So when we find f of 2 minus h, before that just look at the function. Let us see what the function exactly. F of x equal to x square minus 4 upon x minus 2 for all values x not equal to 2. So this can be simplified, x plus 2 into x minus 2 upon x minus 2, and it is equal to x plus 2. So f of x equal to x plus 2 for all values x not equal to 2. So let us find f of 2 minus h. That become 2 minus h plus 2, that is 4 minus h. Similarly, let us find f of 2 plus h, that is 2 plus h plus 2, and that is 4 plus h. Now, as I told you, h is so close to 0, h is positive quantity, however, it is so small. So what will happen when we take the value of h is tending towards 0? So limit h tending to 0, f of 2 minus h, that become limit h tending to 0, 4 minus h, and that is equal to 4. Now let us find what is limit h is tending to 0, f of 2 plus h, and that is equal to limit h tend to 0, 4 plus h. So that also equal to 4. So what we see here, we have seen that the value of limit in both the situation is equal to 4. So I can say that limit of h tending to 0, f of x is equal to 4, and this is called the limit of a function. So the value limit h tending to 0, f of 2 minus h, we call it as left hand limit, as we are approaching towards 2 from the values less than 2, and limit h tending to 0, f of 2 plus h, we call it as RHL, because we are approaching towards 2 to the values which are greater than 2, right of 2 we can say. Look here, so just before 2 and just after 2. So this is left hand limit and this is right hand limit. So the idea of limit is when these two limit, left hand limit and right hand limit, are coincide, are equal, I can say that the function has got a limit or the limit exists. So we can say that limit x tends to 2, f of x is equal to 4 in this example. Okay, so I hope now you understood the meaning of limit. Now use this concept, we can understand what is continuity. Let me define the continuity. Continuity of a function, how we define? For a real valued function f at a given point x equal to c is said to be continuous if limit x tends to c f of x is equal to f of c. That means the limit of a function is equal to the value of function at that point. I can explain this with an example. So let us look at this example, f of x equal to mod x. Okay, we have to verify the continuity of this function. Mod x is equal to x when x is greater than or equal to 0, minus x when x is less than 0. You may remember what is the limit we have calculated. The limit x tends to 0, f of x equal to 0, and limit x tends to 0 plus f of x is equal to 0. So look at the example, f of x equal to mod x, and we know mod x is equal to x when x is greater than or equal to 0 and minus x when x is less than 0. So let us find the limit. Okay. So limit x tends to 0 minus f of x, which means limit h tends to 0, f of 0 minus h, which is equal to mod of 0 minus h when h is tending to 0, it becomes 0. Similarly, limit x tending to 0 plus f of x, which means limit h tending to 0 f of 0 plus h, and that is equal to 0 plus h when h is tending to 0 becomes 0. So, we have seen that left hand limit and right hand limit are equal. So, now let us find at x equal to 0 what is the value of function. So, f of 0 equal to mod 0, which is equal to 0. So, we have seen that left hand limit equal to right hand limit and it is equal to the value of function at that point. So, we can say that f of x is continuous at x equal to 0. So, we can see the graph of mod x, already we have seen earlier. This is the graph of f of x equal to mod x. You can see that there is no point, there is a break in the graph. That means continuous function never have a break or jump or even a gap. So, a function whose graph does not have a break, jump or gap, we can say that it is an example of a continuous function. So, in this example, you have understood that the function is continuous at the point x equal to 0. Now, I will be explaining another example in which we will find out there are functions which are not continuous at a particular point as well. So, have a look at this example. Look at this example now. F of x is equal to x plus 2 if x is less than or equal to 1, equal to x minus 2 if x is greater than 1. So, let us find the continuity of this function at the point x equal to 1. So, for that we have to find the limit. The left hand limit, x tends to 1 minus f of x, which means limit h tends to 0 f of 1 minus h for some positive quantity h. So, that is equal to limit h tends to 0, we have to take the value of function which is smaller than 1. So, clearly we will substitute the value of function x plus 2 over here. So, which means 1 minus h plus 2 and that becomes limit h tending to 0, 2 plus 1 3, 3 minus h, when h is tending to 0 it becomes 3. Now, let us find RHL. The right hand limit here, limit x tends to 1 plus f of x, which is equal to limit h tends to 0 f of 1 plus h. And now, the value of function we have to take which is greater than 1, and that is, look at the function value. What is the value of function when x is greater than 1? It is x minus 2. So, this becomes 1 plus h minus 2, which is equal to 1 minus 2, which is minus 1 plus h. So, limit h tending to 0, minus 1 plus h is equal to minus 1. So, it is quite clear that left hand limit is equal to 3, whereas right hand limit is equal to minus 1. So, what do you observe? LHL is not equal to RHL. So, what you can conclude now, since LHL and RHL are not equal, limit does not exist. When limit does not exist, what is your conclusion? F of x is not continuous at the point at x equal to 1. So, have a look at the graph of this function x y. When x is less than or equal to 1, it is x plus 2. So, let us plot the graph of the function when it is less than or equal to 1, this is a point 1, have a look here, and when x is greater than 1, it is x minus 2. So, the graph will go like this. Okay. So, this is the point, you can see there is a gap over here. So, this is the value of function for all values less than or equal to 1, and this is greater than or equal to 1. You could clearly see that at the point 1 there is a gap between the function value, and so graphically also we can conclude that f of x is not continuous at the point x equal to 1. Hope you understood this particular example. So, we have seen examples in which function is continuous and another example wherein function is not continuous. Now, let us learn some properties of continuity. When f of x and g of x are two functions, then f of x plus g of x, if two functions are continuous, then their sum also continuous. Similarly, f of x minus g of x also continuous, and f of x into g of x continuous, and similarly f of x divided by g of x also continuous, provided g of x is defined at that point. Now, let us define differentiation. Derivative of a function, derivative of a real valued function at a point x equal to a is given by f dash a is equal to limit h tending to 0 f of a minus h minus f of a divided by h. And there are rules of differentiation and there are methods of differentiation. All these we will study in the upcoming modules. So, in this module, what have we learned? We have learned limits, continuity and the definition of differentiation. And there are rules, methods of differentiation. All these we will study in the upcoming modules. Thanks for watching.